Good afternoon, my name is Dave Schwaderer. You can put your pencils away because this one is really easy. Who's heard about blockchain these days? Or who hasn't heard about blockchain? Okay, no hands are up. Good. Okay, who's heard about Bitcoin? All right, everybody's heard about Bitcoin. So we're going to talk a little bit about what Bitcoin and blockchain is and distributed ledger technologies and things like that, with an emphasis on data center planning and application planning within your enterprise. So let's start off. This is the tell them what you're going to tell them. And it's real easy. You can probably fall asleep between every one of the bullets. It's okay, not a problem. Talk about distributed ledger technology, blockchain, on Bitcoin, and the differences between them. Known adoption challenges, the things that you're going to be looking at, and if you can remember them or look at the slides later, might look smart within your enterprise. ICO, initial coin offerings. My goodness, what's an ICO? Okay, then we're going to get to the meat of the talk, which is just storage considerations, and we're going to conclude it. Let's see how much trouble we can get into. Why blockchain? Okay. Blockchain is a spectrum of methods that allows decentralized transactions. So if you do Uber or Lyft, how does it go? You send in a transaction into Uber or Lyft, and then that transaction gets broadcast out to drivers, and then the drivers respond, and you find out what's going on. Decentralized with blockchain, you will go directly to the driver. There will be no Uber, there will be no intermediary, bang, right there, no middleman. So this is a so-called frictionless economy, which is what the internet was supposed to be. The way it works is there are immutable, you can't change it, transaction ledgers files, which represents truth, which is, hey, there's a guy, he does live here, he does have money, there's a driver out there, he does have a car, he is around, bang, things get matched up, no middleman, car arrives. So, it is a combinatorial innovation. And what I mean by combinatorial innovation is in the Google sense, these are very well-known technologies already running in your data centers that are just put together in a little bit different way. There's hashing, and there's encryption, and there's append-only, write-only logs, and locks on devices, and locks on files, and things like that. And the data is interleaved to where you really can't change. Once you commit something to an append-only immutable log, bang, it's there. It's replicated in all different kinds of places. So it's not like an erasure code technology. There are just copies laying around everywhere. So in theory, if you lose your data, you can just kind of like wander on out in the web and grab it again and bring it all back in. Right? Once append-only electronic ledgers. Oh yeah, it's supposed to exist for perpetuity. Perpetuity. I said it, right? Really? You know, forever? Data gets written forever. How many people are running MFM hard disks in your data centers? Do you know what an MFM drive is? Good for you. They were around in 1985. We'll talk about that kind of stuff. So, blockchain. So the blockchain participants, because there's no middleman, they perform the system administration by themselves. And no single entity determines on whether a transaction is true. They get to vote. Did you know that democracy, or the truth is determined by democratic vote? You know, just be careful when to group you hang around you. And so it's sort of idealistic. All this stuff here. So the network systems collectively generate a consensus on, yeah, that guy really does exist, and he really does kind of live over there, and yeah, he's got money, and yeah, like that driver over there, yeah, okay, so let's get it. So there's kind of a consensus now. There are multiple consensus strategies. So here's the first fork in your data center. Multiple consensus strategies. Not one, right? Everybody talks about blockchain in singular. but there's multiple consensus strategies. Proof of, when it comes to generating your consensus, proof of, how about work, proof of state, proof of time, proof of record, you name it, it's out there. All different strategies, all different side effects, all with unintended consequences. But the point of the proof of whatever you pick is you want to make sure that the people that are voting have skin in the game. They're just not somebody that kind of like wandered in off Times Square and into your data center and said, oh yeah, that's right. So you make people commit some effort. And we'll talk about some of the side effects on that. So the deal is with all these distributed systems, all this replicated data, and it's all interlocked and you can't change it. It's going to last forever and no device ever fails, and everybody can talk to everybody because networks never fail. You have to hack every system. And there could be, hundreds of thousands. There could be millions of systems, or there could just be a few, depending on the kind of blockchain that you have. If you have a public blockchain, you got to watch out for the people out in Times Square, wandering into your data center saying, oh yeah, that guy's, he's for real. Yeah, give him $150 million. There are other kinds of blockchains, permissioned, and these are very, very close. And these, ladies and gentlemen, are the kind of blockchains that you're probably going to be having in your data center, permissioned. Only certain people can get in, and you will have cybersecurity locks and testing and things like that, perhaps holding things that you don't have now. So Bitcoin and China. This is interesting. Bitcoin is an example. We're going to get into Bitcoin in the next slide. Bitcoin, there are pools of people that vote, and they have hundreds of thousands or millions of processors, some of them on GPUs. They're running, maybe it's an NVIDIA 1080 with 4,000 little engines running on each GPU card, and they'll have 6 GPU cards, and they'll be heating up the planet as they do it. The 5 largest Bitcoin mining pools, the guys that vote and go looking for the truth and things like that, they're in China. Did I mention that truth is determined by democratic vote? Well, guess what? The 4 largest Bitcoin mining pools are in China. They have more than 50% of the votes. It's over in China. So that's kind of exciting. You bet on China when you bet on Bitcoin at this point in time. There are apparently 200 startups working on their own distributed ledger technologies, variations of the so-called blockchain technology, 200 different ones. So you have to ask yourself, and I'm sure you know the answer, what are the odds of interoperability? Right? They're fighting every day to survive, not to interoperate with the other 199 guys. So they're all out there milling around like blockchain. Now, so I mentioned DLT, distributed ledger technology, blockchain, and Bitcoin. Let's distinguish between them. This will be a useful chart for you. It's very simple. DLT, distributed ledger technology, this is where there's a bunch of these immutable files that are sitting out there, pinned only, write once, logs, and they're shared. So it would, whoops. So that's it. So that would be the space of DLT. There is a sample of them, a subset of them, and those are called blockchain, guys. So there's a difference between blockchain and distributed ledger technologies, right? Distributed ledger technology does not necessarily use blockchain, but Bitcoin is one kind of blockchain within distributed ledger technology space. Where did it come from? I said it was a combinatorial innovation. Its origins for blockchain were back in 1991. It was a paper, and that paper was cited 4 times in the paper that discussed and revealed the existence of the Bitcoin mining network. So this is stuff that's been around, what, 27 years? So it was an overnight success after 27 years. Well, after about 20 years, it was an overnight success. So this is the beginning of it. It's been around a long time. It is a combinatorial innovation. It wasn't all there, but most of it was. Now let's talk about some of the adoption challenges that you as an enterprise data center person are going to be grappling with. First of all is performance, scalability, and I mentioned interoperability, right? So if you're doing financial transactions, can somebody give me a number as to how many a second you think a large, widespread financial transaction base, how many a second would you do? Come on.
50,000.
50,000. Boy, that's a good number.
But it's too small.
That's a good number. You're going to see that number again. Just a second. All right. Good guess. Wrong. Is there some part of the word no? Okay. So, data mutability. Go ahead, store some personal data. The EU will find you. And guess what? You'll have to erase it, which changes the file. Right? So, headlong collision with the EU privacy laws, for just for example, is a problem. So if you think you're going to be putting in an immutable data set in your data center, you want to talk to the people asking you to do that to make sure they really mean it, because it could be trouble. Now, consensus proof of work. Okay. Don't want to get into the details, but it's a GPU burner. When I say burner, it turns out that they have farms of them over in Iceland. And the farms will be consuming more electricity than the population of Iceland within a year and a half. Now, do you think that's going to work? And the answer is no, that's not going to be. What have data centers been doing for the last 20 years? Figuring out how to extract every value they can out of every joule. Technology versus replicated data storage in perpetuity. There we go. Public block visibility. So the data is encrypted, typically in a lot of applications, it's encrypted, sitting out there. But guess what's sitting right next to it? The public encryption key. And what's going to happen if and when quantum computing comes? It's going to cut through that stuff, and all your x-rays and your medical records are going to be sitting out there. How about that? Right? So these are the kind of questions that if you're getting hit up in an enterprise, we got to do blockchain. Really? Okay, well, let's think about it. Okay? Programming and architectural errors. The art of debugging is not to find programming errors, it's to find architectural deficiencies and oversight. 150 or $250 million disappeared out of one fund. It's called double spending problem, because they got into an interim state within a program call, and then they recursed and called the thing again and again and again, and so they spent the same $10,000, $50,000 or $100,000 or 200,000 times, sucked about 150 or $250 million out in just a matter of hours. And this was an implementation called DAO, the Digital Autonomous Organization, that had billed itself as building the most bulletproof code in the world. Error-free code. Good to know that it's here. So, human fallibility versus smart contracts. There is capability in Ethereum, which is a seriously interesting blockchain implementation. And if certain conditions are met, you can program the system to execute and pay or do other things, whatever you want. Maybe transfer title of a house, your swimming pool, whatever. There was a gentleman in the 1980s, I remember, reading about him on Wall Street. And he would go up and down Wall Street, and he would bet Wall Street $1,000. He'd go into a company, bet him $1,000 that they could bring him a moderately complex spreadsheet. He could find an error in it. He never lost. His gig was as he taught classes on how to write good spreadsheets. Right? This is smart contracts are programming guess what's going to happen? Somebody's going to lose houses and all that other good stuff. So it's very tricky. And you don't want to be the guy that loses your parking lot because you did a smart contract incorrectly. Hacking vulnerabilities, there are unknown unknowns. And none of us have omniscient infallibility. So you want to understand that you are wandering into something that has a lot of unknowns and unknowns. Participant squabbling. There was an ASIC that was developed that wasn't as fast as a GPU, but it was certainly faster than a single processor. And it began to be sold. Both the guys that were doing their mining and processing on GPUs and processors said, this isn't fair, let's change the algorithm so their stuff doesn't work. Didn't go through, but they tried it. So, democracy goes so far. Initial coin offerings. Does anybody know what this is? ICOs? You see the term though, right? ICOs? Okay. Well, it's a GoFundMe basically. Now listen, I'm a nice guy. I'm a really nice guy. And I'm developing this thing, I can't tell you what it is. And it's going to do really neat, and you're going to love it. And if you give me $50,000 per script that I'll give you, you'll get first rights at buying it. But I can't tell you what it is, but you're going to love it, right? That's what these guys are doing. Now, you think I'm exaggerating? I am not. Okay. ICOs, 1,706 exist. If you go to, I think it's CoinCap.com. That was at that time and that date. There were 1,000. 4-month time to live. Send them boatloads of money and it'll just sail right over the horizon. 56% of them that have lived are zombies. They're not going to go anywhere. So, kiss that money goodbye. Bitcoin metrics. Here you go. The entire database for Bitcoin is about 200 gigabytes, I've read. It does 7.0 transactions a second. That's what it does. 7. Okay. And well, let's compare that to reality. 200 gigabytes. What if you were storing X-rays? What if your blockchain was going to be an X-ray storage thing with encrypted? Everybody was going to be able to look at should quantum computing come out. Well, it wouldn't be 200 gigabyte database. I'll guarantee you that. Visa does 50,000. And that was a good guess. 50,000. One of the estimates was about 56,000. So there you have it. What's it? I don't know. 5,000. It's just amazing. There's one startup called Evio that claims they can do more than 2.5 million a second. So you can bet, because of the energy requirements for Bitcoin, because of its scalability, because of its performance, all this kind of stuff, it's going to change. But remember, your database is not allowed to change. So now here we are, the takeaway. What are the storage considerations for you? Flash Memory Summit. 2013, the first keynote was Facebook. And I have to tell you, it was one of the greatest moments, not the greatest, but one of the greatest moments in Silicon Valley I was privileged to witness. Jason Taylor came and he talked about current state, future potential, and it was Flash Memory Summit keynote. So he's talking about Flash and Facebook, right? So this is it. This is kind of like one of his slides. This is where we were back in 2013. And I draw your attention to 350 million photos. Photos are immutable data. And how do they store it? Well, they collect it all, and if you read the newspaper these days, they kind of keep it all. Other people wind up getting it, their hands on their stuff. So it's accessed for a while, and then it goes cold. So he was talking about cold flash. Cold flash. The Facebook ask, make the worst flash possible. The worst. Make it dense and just make it cheap. Long writes, no problem, right? Low endurance, no problem. Low ops, low IOPS, no problem. He says long writes takes 10 times as long, no problem, right? Low endurance, immutable data. We've been talking about immutable data. The probability of this data will only be written once and read never. Yeah, read never is probably the spec for a lot of this. That's the kind of class that you're talking about. So you don't need NVMe at 7 transactions a second. You may need it to scan the database if you're into quantum computing and you're sucking all of the encrypted data out and decrypting it because you've got quantum computing. But this is a very unusual request for a cold flash. But immutable does not imply cold because you do have your data lifecycle. So when you do your blockchain applications in your enterprises, you're going to have to keep track of your data lifecycle. So this is it. We're not going to do a tell them what you told them thing here. Blockchain is in its infancy. Take that to the bank. Right? Do not bet your career on it being stabilized. Blockchain washing. Does anybody know what I mean by that? Right? When green data centers were coming along, right? They were saying, oh yeah, we got green data centers, because our concrete is, doesn't off-gas as much CO2 as the next guy and all this other kind of stuff. Here's what I mean by blockchain washing. The Long Island Tea Company. I mean, a company that leaves you boil and water, and you drink, tea, Long Island Tea Company, changed its name to the Long Blockchain Company. Stock went up 500%. Didn't do anything, they just sold tea. They're getting inquiries now from the Federal Trade Commission. So, I'm serious. No, you can check it out. This all there. Okay, so there's an industry stampede in process. Now, understand that there is money to be made in chaos and churn. So you can play a role here. But there's probably going to be either a backlash or a significant enterprise pullback. 98% of the projects are supposedly kind of like pulling back within enterprises. So consider it an aspirational to adopt it. People that are coming in and asking for it probably don't know what they're asking for and why. It's, ad hoc, roll your own stuff, and it's not interoperable, so you're going to have data islands, right? So are significant changes inevitable? Yeah, significant changes are inevitable. You can capitalize on that churn. Final slide, I do believe. Storage requirements requires escape fires. Back in 1952 or so, there was an incredible fire. They dropped some smoke jumpers into it. The wind reversed, and it was coming up the hill, and it was coming to get them. And I mean, it was coming to get them. They were all going to be dead, cooked in about 10 minutes. So this guy that was in charge of him, his name was Wagner Dodge. They call him Wag Dodge. He did something that had never been seen before. He ran up the hill slightly, he took a match out of his pocket, he lit it, and he threw it in the grass in front of him as the fire was closing in on the back of him. The wind blew the fire up the hill in front of him. He walked into it after it had stopped, the flames had stopped. He stamped out the embers, and he laid down with his blanket, and he was about the only guy that made it out. It's called the Man Gulch Fire, one of the most heavily studied fires in our organizational events in history. And it has to do with organizational overrun, getting overrun by events. So, you have a fire coming for you, possibly in your enterprise. You're going to maybe play a role, maybe an important role. So, you're dealing in a world of shifting technologies, right? From diskettes, zip drives, IDE, to MFM, like I said, UDMA, parallel SCSI. Nobody uses that anymore. That stuff is basically dead within the industry. Your flash, your NAND flash stuff is going to be dead. Your vendors are going to come and go. But your data, if you watched carefully, is going to have to live forever. on stuff that is technology that's shifting and vendors that are coming and going like a New York train station. HDDs are now moving to CMOS SSDs, but it's CMOS. What's going to come after? If it's not CMOS, there could be serious unintended storage consequences for you. So, predictable, you can predict for sure that there's going to be migration and recovery. Theory versus practice. Great disputed Einstein quote. Right? In theory, you can go out and get your data from some other place in a blockchain. Right? Einstein disputed quote. In theory and practice are the same. In practice, they're not. Conclusion, maximum surprises. Like think self-driving cars. I was in Goldman Sachs on Wall Street, teaching them up. There's no shortage of these ICOs and frauds. This is a Wall Street Journal article. There's another one today about pump and dump in forums. There is so much fraud, it probably make this woman blink. My gosh, good old Elizabeth there. So there's no shortage of chains. Do join blockchain, get on the bandwagon, study on it. There's edx.org. If you write one thing down, write down edx.org. Okay, we're all done. That's it. Charge for your specifications. I'm out of here. Boom. Thank you.